Okay. So, so like I said, really the aspect of the project that we focused on was a screen system, and that's the whole presentation.
That's right.
Okay, there we go. So Chuck came to us about a month ago now, and he kind of gave us like a design brief, and really it was pretty short, which is actually good because that's what you want a design brief to be. You don't want to have too many parameters that are controlling the design. And you know, he said we need to develop some kind of screen system for this form. Right? It should incorporate 3 different factors, and one of the factors was that it should contain ruled surface geometry. And the reason that it was going to contain ruled surface geometry is because the overall forms were actually employing ruled surfaces. The second component was that it shouldn't be kind of a direct translation of an Indian jali. And a jali, it could be it's the same thing as an Islamic screen, or any of the mobile screens, but basically it's kind of the Indian derivative of that. So we were to kind of stay away from a direct translation of it, but it should be a modern interpretation of this kind of very unique historic piece of architecture. The other component was that because the screen was meant to be performative, it had to have some kind of depth. So it was going to be used for shading certain parts of it, even though we actually never got into environmental analysis and kind of shading pieces of it. But the skin should be kind of responsive to the sun in some kind of way. Something that we then kind of incorporated into the screen, and this wasn't the first direct ask, but it was the request to have the screen be opaque and transparent at the same time. And the reason for that is it's a museum. There's a lot of opaque surface, right? So the screen should have the ability, aside from kind of opening and closing, it should also have the ability to go from opaque to transparent.
Right.
Yes?
Can you say why there wasn't environmental analysis?
There was just not any time for it, and it wasn't one of the project priorities. Yeah. You know, that being said, Alan and I, we were brought in 2 weeks into the competition, so I don't know what the iterations of the design were until we were actually brought in, or what the project narrative was.
Right? We're already responding to some forms.
I mean, basically, we were given a form, and we're just like wallpaper, apply a skin to it, right? And so, there, you know, ideally, what would have happened is we're kind of brought in at the very beginning with the project team so that we can influence it a little bit more. But for us, it was just like we got a form, you know, apply to this, and that was actually one of the challenges with the project is that, you know, the system that we developed didn't necessarily work with the forms that were being created from the project. So a ruled surface, you like to have 4 sides to it. There were a lot of triangles. So one of the things that we requested from the team was reduce the number of triangles that you have because the system just doesn't work with it. So we went through a really quick kind of design mock-up process, and I don't know if it was because Chuck's brief was so succinct, but basically we were able to go from, you know, design brief, and within 2 days we had a working iteration of the design. And so it was just like Alan and I sitting down, sketching things up, modeling them up quickly, understanding how this thing would begin to transform, you know, across a surface, going back to sketches if we needed to. But this whole process happened in 2 days, right? And I think like that's one of the reasons that this project was actually so successful, and we were able to kind of hit the project milestone, you know, at the end of the deliverable. Oh, the original gangster. So just to show you guys like this initial 2 days, obviously it's condensed down, but you know, I didn't want to like resketch any of the initial sketches because like look at how ugly they are, right? Like it was just to get an idea down so that we could get, you know, from here understand how we were going to get, you know, depth, how this thing was going to translate across the surface, and get it into something that was a working model that could then be made parametric. So once we had a working concept, right, which is this thing. We really had to start to understand what the parameters were that we were working with. And for this, just think back to the original design ask, right? Ruled surface, not a jelly, and it has depth, right? Like those were really the only things, oh, and it had to be opaque and transparent. Those were the only things that we were really responding to, which actually made this much easier. So, you know, when you're building in parameters into your surface, right, into your module, understanding that this thing has height and width that it has to be able to accommodate, and it also has a depth parameter that it has to accommodate. There was another, so this design ask about it not being jelly, right? That's how we derived this initial form. And depending on how closed or open this thing is, right? This is the opaque module and this is the open module. We could vary the degree of kind of opacity and transparency that this thing had. The last parameter was how open or closed the pattern was, right? So we had a opaque surface, we had a transparent surface, but we also had a pattern that was rotating open and closed, right? And so we had different degrees of, we had a different parameter space for each of the modules, right? So it was divided into 12, and then, you know, this thing could just kind of move along that parameter space. Understanding what the control geometry was, right, was very important. So being able to define a module that actually that is just a skeleton for the actual piece of architecture is something that's incredibly important. And because, right, typically this thing is something that's very simple that becomes complex really quickly once you start to actually put geometry on top of it. And so for us, it was really important to understand these two concepts, the concept of morphology and the concept of topology. Now, you know, we use these terms a lot in architecture, but I really wanted to define them here because they're kind of misunderstood. Topology, right, and when we're working kind of, you know, maybe at this level, right, topology is the study of geometric properties and spatial relationships unaffected by the continuous change of shape or size of the figures, right? So when we're talking about topology, we're talking about the number of sides, the number of openings, the relationships between different surfaces, right? So here we can describe this thing as, you know, a surface that has 4 holes in it, and that's its topology. What the shape of the surface is, what the shape of the holes are, topology doesn't care, right? And so when we're developing a system, understanding, you know, the continuity of its topological surface, and then also understanding the different topologies that you have within the system were really crucial for us. Morphology, on the other hand, is the study of forms in particular. So once we have kind of the base, you know, the base topology of it, how we then scaffold, you know, what the form is actually going to be on top of it is the second step. And this step was basically taking, you know, this kind of diagonal cruciform shape, and then assigning it sectional properties. And you can see here that we introduced this conic section into it, right? So from it just being a, you know, 2 ruled surfaces that are intersecting each other, we were able to introduce a conic here, and that's what actually became the ruled surface for us, right? So there's a difference between, you know, understanding topology and then what the additional morphology is on top of it. You know, how we interpreted the original topology, it could have been anything, right? There are a lot of different ways that you can translate this initial form, but the initial structure of it must be maintained. Okay. And, you know, talking about topology, there were 3 main modules that were developed. One was completely opaque, so you can see here that it's opaque, and Chuck called it a bow tie. So when we were talking about these, right, it's nice to give them names. So we called one the bow tie, and the other one that was open was called the propeller. And because we had 2 different necessities, right, one being opaque, one being transparent, there had to be some kind of connector. So this was the bow propeller, or however you want to call it, propeller, or the prop tie, which kind of stitched the 2 together. All right. So I'm going to pass it over to Alan. He'll talk a little bit about the system logic.
Yeah, so the system logic is basically completely integral to the module logic because you're basically developing each one in tandem. So understanding how your module will then tile then informs directly what that system is. So we first needed to break it down into its most simple components. The first thing is it's a checker pattern, basically, as it tiles. You have your pink module is can be uniform across for each one, and then the blue module is the mirror version of that. So as you tile it, you can tile the same two panels essentially, one a mirror of another. And then basically just connecting the lines along an edge parameter. So as long as that common edge parameter meets, you can connect the lines to construct the pattern. To get the backside, so basically how we had taken the ruled surface and lofted between a top and bottom, yeah, like that. You're just mirroring the top pattern. So you can imagine on this logic, now you just inverted the pink and blue checker pattern, and you're just laying them on top of each other. So that creates the basic tiling structure.
And that was really like how we got the depth from it.
Yeah.
It's actually a really simple logic. You know, it wasn't really rocket science. So look at the center pattern right there, right? So from Chuck's ass to not be a jelly, right? Do you guys see a similarity? Yes. Yeah. So we actually didn't know that this pattern existed when we created the original module. It was only after kind of searching through kind of inspiration images that we found this. And there's a tomb called the Tomb of ShivNadar, and it's located 3 miles south, 3.5 hours south of our site. So talk about being contextual, like we nailed it.
All right, so moving on from this, we needed to separate logics between open and closed panels, since part of the problem of the project itself was in a museum space and the cultural center space, a lot of the building needed to be totally opaque. So we started to develop diagrams. We knew what the open logic was because that's essentially where we started. So the closed logic came later, but it was still derived off of the same pattern. And what we were doing there was basically just, okay, so what if we take, instead of lofting to the back edge, we just directly use the endpoints and create more flat panels. So we're just filling in the gaps using the same pattern. And then the transition model is basically is how we're going from closed to open. And it's just a hybrid of taking part of the closed piece and then putting an open piece onto the edge of that. So
this ask really was, we didn't really understand where the screen was going to go. And so initially it was going to be on the inside where it was supposed to be completely open, where the screen made sense. But then we inverted the scheme so that this skin was actually the outside of the building, and it was kind of the signature moment for it. So, you know, it's so then they were like, oh well, it actually needs to do two things, and that's the point in the project where you're just like, fuck, man, like now we have to change everything. Yeah, so we kind of went back to the drawing board, and we were like, you know, at that point you're kind of all frazzled, you don't know what's going on, so we didn't figure it out that day. But then the next day we came in clear-headed and we're like, oh, it's the same pattern, we just have to connect the edges differently.
yeah, so getting on from the system and how it basically tiles, another component of this is the pattern transforms itself. So we can basically have any kind of control geometry. In this case, it's a curve, and you're basically controlling where the edge parameter meets on each of the tiles, and it meets closer to the corner point of each square, the closer it gets to the geometry that's influencing it. So as it gets closer to the curve, the tiles get, the edge matching gets closer to the corner on each one. And as it moves away, that's where the pattern becomes more open. And like this is essentially how we're also kind of controlling the amount of light, and it also adds a nice configuration, at least as a patterning system, because it makes it easy to more seamlessly transform between the closed panels and the open panels.
And this will make more sense in in a few slides down. You'll actually see like what the system was that was used to control what's open, what's closed, what's opaque, what's transparent. So getting this idea down of kind of a morphological transformation, which is like how this thing actually changes shape. I don't know, like we found Escher afterwards, so we're kind of like layering something onto it that wasn't really there during design. But Escher, of course, does these beautiful, he has like 3 metamorphosis patterns that he developed, or drawings, I should say. But basically, it's not just a space-filling tile, but it's actually a morphological transformation, right? So, I don't have a diagram that explains the full transformation, but he's basically using this hexagonal pattern here, which you can kind of see, I think, in its most pure form here, right? And he's modifying the form in one direction, and he's modifying it completely until, it's completely deconstructed in the other. So when we started this, transformation between kind of the most solid tile and the most open tile, we really had to understand, what are all the different changes that we're going through, kind of as we progress from, one piece of the pattern all the way to its most open, right? And so in this case, when you're thinking about kind of tiling and transforming between tiles, it's really important that you define, okay, well, what is my initial condition and what is my end condition, right? Because without those, you actually can't figure, you really don't understand kind of all the steps that you need to go through. Right? If I was like, oh, it's just this thing gets deeper and deeper, it really wouldn't tell me about like what this thing has to be at the end, right? So in this case, we understand first tile, we understand last tile, but then we also have to understand how this thing gets deep, how it rotates, right? How the pattern rotates out, what direction we're going in, like this initial diagram that Alan did, right? So what direction is it going in, and what is the pattern length? And the pattern length was actually something that was kind of really critical as this thing transformed across a surface, because you needed to give the pattern enough time to run out. If it didn't, then it actually didn't look like it was doing anything, right? It just looked like a pattern. So again, tiling depth, understanding what the calculus was, right? How this thing actually transformed. So, there was a lot of study that was done just to make sure that the gradation of this thing over a large surface looked smooth. And so here's just a section of how that actually happened. And all this just to make a control pattern, right? So getting your control pattern down, which essentially kind of dictates, the rest of the project, which is really trying to understand concepts like, okay, well, how is this thing transforming? How many modules do I have? What is it doing to the morphology of the form, right? Because here we have an opaque panel, here we have a completely open panel, and they're actually, the morphologies of them are different. And how do we maintain topology between them, right? And that was done, like as Alan had explained before, by keeping the pattern the same.
All right. So how do we transition from opaque to transparent? I have no idea. But, no, we're basically setting this up, defining each area by a surface. So we're drawing a surface to where the patterning needs to be opaque and where it needs to be transparent. And then in between that is basically the transition between the two is where we have our stitching tiles. So we're defining all of our opaque areas, and then at the end of that, basically furthest away from our transparent areas, the tile gets flat. So we want it to the relief to sort of flatten out and dissipate to where it gets totally transparent is where we want it to be the deepest. So something with the geometry of the deep modules, we really need those to be as thick as possible. So in the final design, just because of the way the rule geometry is constructed, it lends itself to being pretty thick. So we're basically just having a gradient between it's flat to most deep, which is also an opaque and transparent binary. So we can iterate through various schemes by showing, the first one, the open and closed, is essentially where we're defining our open surfaces versus our closed surfaces. And then that edge line is what basically dictates what the pattern transformation is. So it transforms in terms of patterning, to its most closed around that edge condition, and then it opens up as it gets further away. And then we can also see this in terms of its depth. It's the most deep around where the opening is, and then it tends to flatten out. We want it to be flat in certain areas, so those areas are at the edge and away from where it's the most open. And then that then manifests itself into the tessellation.
So I would say that, we obviously designed the module, right? And we designed the system, but from kind of a designer's perspective, if we could even talk about designing in that way, right? This is where the design is actually happening, right? So because you're taking, what is my overall form? Now you're basically just, at a very schematic level, defining what you want to be open, what you want to be closed, how you want this pattern to transform across the surface, right? And now you can begin, you built up this entire system, right? Where you don't want it to just end once you've finished designing the system. Now you want to take that system and you want to be able to iterate through different design options, right? And so this is really where the design happens. And the reason that you want to set it up in Grasshopper is because now you can iterate really quickly, right? You don't have to, spend a lot of time transforming the module. You already have the system in place. Now you just want to iterate as many times through, right? All of the rules that you've already set up. So, being able to iterate through these different options, right? And this is just for example to show, right, how quickly you can take one form and apply different patterns to them.
Because this is set up as a system, so because you have the system logic, basically what you're doing is you're just defining where the rules of that system are placed in the model. So here it was like super easy for me to just draw in a few surfaces and curves in space, and basically to make these 3 iterations, it took less than an hour to actually get the geometry iterated out. So it's just it makes it very quick, easy, streamlined. Once you have the system set up, you can iterate through it.
Yeah.
So you can see version 1 versus version 2 and version 3. So while they take on a similar characteristic, they're all different and distinct just by nature of where you're placing the rules. So you're basically designing with the rules of the system that is created. And basically what's different here is the different inputs are different. However, the parameters across this are totally the same between each one. They're the same spacing, the same depth parameters. Those are all things that you can even change and iterate. So you could change, so that's one way of looking at it, is changing the shape, but then there's also a parametric component once the system is set up.
And I think it causes us to analyze kind of a design differently, right? Like when we look at a design scheme that we produce, right? We're just what is it about this design scheme that we like, right? When we're looking at it in a more parametric fashion, what we're actually looking at is the difference between schemes, right? So we're comparing one scheme to another, even though they kind of rely on the same systematic logic, right? So, working with some of you here, right, when we do any kind of analysis or parametric manipulation, a lot of kind of what we say over and over again is until you produce 2 or more, right, it's only going to give you so much feedback. The feedback starts to happen when you're able to produce, more than one option, right, in a quick and rapid fire way. Here's some images just of the 3D prints that we produced. These prints were they were very successful in our opinion. And we started with, I think this was the first print that we did just of a task pattern. And this was a full, once we had the opaque component to it, right? Going from an opaque system to an open system. but doing this, it kind of gave us a completely different view of what the screen was. It caught shadow differently. We were able to backlight it, and really using the 3D machines. Like if we didn't have these, like we wouldn't have had this kind of, the feedback of the 3D print. And we took these 3D prints and we put them on the boards that were taken in India.
What else is going on in that photo? There's a lot of color.
Oh,
Chuck's magic.
I think it was a mistake actually. Like how did this? I actually wasn't here when it was put on the light box. So it was sitting on a light box with some kind of acetate below it, and like Chuck lit it. You turn the light box on, and I think Alan just was like, "Oh, that looks cool," and he took a photo and sent it to me.
But
Yeah,
that's the colors are part of thinking about the character of India as we understood it, is that they have an incredible sort of passion for intense color. So we knew that we're going to deal with color in some manner, and I think this is more of just a kind of prelude to how color might enter into the project. And I think Brian was actually really intrigued with the idea of, can this skin now have two different colors, because it has an inside and outside, and as it opens, it reveals a whole sort of formal complexity that might be driven by just the color.
Oh yeah.
And and ultimately in its manifestation, if it were to go forward, it would become like kind of a sandstone red color. So it would be something that would be very responsive to the vernacular use of this red sandstone that seems to be very prevalent in this area.
So, when we kind of do all of this stuff that seems very logical, we always have to ask ourselves, like, is it beautiful when we're looking at it? And, I really, like, we spent a lot of time just thinking about, like, what is it that actually gives, a form, that it factor, right? Like, what makes it kind of beautiful? And when we were looking at this specific system, right, we already talked about topological specificity, and I also want to talk about geometric divergence as the two fundamental criteria of beauty, right? So things have to have, they have to have structure to them, right? A form has to have structure, but it also has to be divergent in terms of, is it ambiguous? Is it varied? Does it transform, right? These are all kind of forms that we find in nature, or logics that we find in nature, that we are just drawn to. Right, so we just listed a few of kind of the factors of what we think actually make this thing beautiful here, and I think geometric clarity is kind of an obvious one, right, because it gives structure to the thing that we're seeing. Ambiguity, right, there's a lot of ambiguity in the ways that you can read this form, right? You can read it as kind of a propeller form, you can read it as the initial cross. I've highlighted a few of these kind of in the next images, but there's this notion of transformation, which kind of brings the light to our eyes. Also, this concept of newness. I was listening to a podcast the other day, and I forget who it was, but basically they said the two things that make it interesting for us as humans when we see a new idea is this idea of kind of conciseness, right? Like having a really clear message, but then also having it be new, right? Clarity is definitely one thing that makes an idea interesting, but just not having heard it before or not having seen it before is another integral component of what makes things kind of, surprising and curious and, engages our wonder. And also, I think just inherent in the form itself, because it's organic, being geometric but also organic at the same time is another factor. So we just did a bunch of these diagrams, which is highlighting kind of the different factors of this, right? It's opaque and it's transparent. It's undulating, right? And the undulation transforms across the surface. It's a bow tie and a propeller simultaneously, right? And the two go in different directions. And there's also this kind of secondary read that is not really inherent in the geometry of it, of just the shadow line, right? And the shadow line transforms from a simple bas relief, and then eventually it kind of describes itself in this like sinuous kind of pattern along the form. And so that's why you get this really strong diagonal read on the actual system. And altogether, it looks like this. So these are just a few images that we produced. Again, these weren't included in the final proposal at all. They were just kind of progress images that Alan and I shot as we were kind of putting this thing together. And so I actually don't know. So we shot this, but I don't know who on the team put a red background behind it. But it just looked awesome. We still don't know who it was. It could have been Lauren.
I did that.
Oh, it was John. Yeah, it was John. And you know, when we colored it this way, like really, another read on it, yeah, we get like the shadows and we get the transforming geometry. But just understanding the figure ground on it was like another really big area of interest. Here's just some shots. And so you can see here, like the flat to the gradation to open. And really giving this thing enough room to transform was when it was most successful.
These are out of Enscape.
These are out of Enscape, yeah. Enscape's just amazing, by the way. You guys should all be using it.
Are the forms here mapped over the massing that the project was
Yes.
looking forward with?
Yeah. So, like, just think about it in this kind of fashion, right? We got a form, and then we applied a pattern to it.
What was that translation process between, so you were describing kind of like those guiding curves where the system then responds to?
Mhm.
I imagine there was some relationship with like program as well.
Yeah.
Could you talk about just like that a bit?
And I think that's the way that you evaluate the geometry and development is, how is it responding to what's behind it? Because some things need to be transparent and have visual access, others need to be totally opaque. And I think that we're thinking of this as a energy saving device that's going to shape the building intensely when it's necessary. And I think as if this project were to go forward and were to be developed to the next level of thinking, we'd have to scale the module. We would have to find out how many different transitional pieces we could build into the system and have it be precise and still allow us to have an elegant transformation.
Mhm.
We would have to figure out the material properties of what the thing is made out of. There would need to be a series of, like at a micro level, probably a joint that would allow each unit to join to an adjacent unit with a small amount of variability, because the building itself is not a perfect Cartesian rectangle, it's distorted, and that distortion would have to be absorbed within the individual unit. But you can't have every single unit be unique because of the cost effectiveness to it. So then it's like, how do we begin to think about building all of these issues into a further refinement of how this thing would actually manifest itself.
How much did you play with scale during the competition?
Good.
So the scale of the module, how much did you play with that while working on the competition?
We kind of, I think, relatively quickly just said it's going to be like 1.5 meters square. So it's like a 5 foot by 5 foot, 5.5 foot. And I think it felt very comfortable. We knew that the depth couldn't be excessive, like it couldn't be like 1.5 meters thick. So when we started to scale the thickness of this thing, it started to suggest what the kind of elevational scale would be. So I think, and again, it'll all be a function of the thicker it is, the more material you will use to realize it. So if you have to compress that, right now I think it's somewhere in the vicinity of about 400 millimeters deep, which is about 16 inches. If that has to get compressed down to 12 inches or 10 inches as a way of reducing material, that would be another parameter that would start to sort of emerge as the thing would get developed. And I think that because Alan and Brian did such a beautiful job of like being able to control the sort of events that determine the particulars of the geometry, that it's possible now that they can make these adjustments relatively quickly. You can see what the consequence of that adjustment is, and you can kind of begin to find the right fit between the dimension of it, the scale, the density, the amount of change, all of the sort of features that you're trying to control at the design level.
Yeah, I mean, there was a lot of back and forth actually, to Nick's point, just about like where the pattern's starting, where it's ending, how flat should it be, how deep should it be. And I think one of the things there was consensus around, there was not a lot of consensus around like, oh, where should it be opaque, where should it be open? A lot of the consensus was around this thing needs to actually translate through all of its different states in order for the form to be interesting. Like if it's just deep and opaque and like really reticulated, it's not that interesting, right? Like you might as well be looking at a blank wall. It's because it's able to go from like flat to deep to bas relief to then open to then transforming the geometry of it, right? Like that's actually what makes it really interesting because it has all of these different readings. So, so those are the images. We did a few videos too, and you know, we'll just kind of watch these. I don't know if anybody has comments, but I will say that this is not to pitch Enscape again, but it's so easy to do animations in Enscape. And the first reason that we even started doing these Enscape animations was to understand how the sun transformed over the surface. So those are going to be kind of at the end of the final videos that we see. These are more kind of fly around videos so that you guys can see the final form. This presentation is interesting, and like we noted it as we were putting it together, because like you actually haven't seen the project yet. So this is going to be your first chance to see the project. But we just teased the whole way through.
And also to speak a little more on Nick's question, is we eventually just sat down with the team and we didn't know what any of the program was at all really, or where it was. So the team just had to come by and just like literally just looked at the model, say, all right, there's an opening here. This is where such and such program that needs to be open is here, there, and then we just like sketched it out really quickly on the model. So, and that basically determined what it was for the rest of the process.
It's beautiful. Yeah.
I think even though this is a kind of simulation of moving through space, that what is not maybe as evident is that the surface is highly sculpted, so it changes as the sun moves, it changes as you move, the shadows that are cast by the openness change as the sun moves through the sort of the cycle of the day. So it's an incredibly dynamic phenomena that it's being achieved through a static principle, that the object is completely fixed and there's no moving parts, yet you can experience it in a kind of infinite number of ways depending on the vantage point, time of the day, and the kind of porosity of the skin itself.
Did you submit a material for the competition?
It's
Do you have any interior animation?
accessible.
Yeah.
Interior animations?
From the interior side.
From the interior? No.
Well,
Well, we do have a few. We didn't put them in here. Yeah.
It'll be
So,
cool.
Oh, no. There is one. There is one.
This is
It's
on the
coming up.
train.
yeah,
This was on the train.
this is like you're riding the train and they just took the roof of the train station off.
We've abstracted. We abstracted it a little.
You have a suggestion to make?
There's actually a roof on the train which blocks the view. Yeah. So this is an interior.
I probably missed this, but how many unique pieces are there in this?
Hundreds.
Yeah.
Thousands. No. I mean, really, we reduced it down to 10, or at least that's what we told the client. But the reason that there's so many is not because the system actually, like on a flat surface, there would only be 10.
Yeah.
It's because it's a ruled surface and there's so many different curvatures that are involved in the original geometry. So if we could rationalize that, then there wouldn't be as many. And actually, because it's a ruled surface, it actually makes it easier to rationalize because like right? A ruled surface is just made up of straight lines, right? So if you can just make sure all those straight lines, if it's the same curvature, then theoretically it's going to be the same module.
So what is the ratio of time? I mean, so it seems like the most taxing portion of this process is to develop the system, right? And then you're saying, then you're applying it and you're designing it in relation to like program and whatnot. But what was the ratio of time spent in terms of developing a system and then applying it to kind of like that surface?
The system takes the longest.
Yeah.
But I would say like half then.
No, because applying it to the surface, well, it's kind of, in a way, you have to develop the system around the surfaces too. Like, you have to develop it around the fact that you're applying it to a surface at all. So that's part of it. So like some of the way that you're moving points in space computationally, you're deriving that basically off of an original surface. So you got to set it up so it's all. So even when you're designing it flat, you want to know that that flat thing is actually a surface as well. So conceptually, it's the same thing.
But we were applying on surfaces within the first week, and I would say in like within Grasshopper we were in like 4 days, 3 to 4 days, and then it was like working through the different designs, and because the design was actually not even baked when we got it. It was just two L shapes, and then it started to get funky, and then we're like, Kyung, calm down, and it's like, I'm gonna do what I want. And we're like, no. Designers will do what they want to do. So.
Could this be an NEN screensaver?
I just did it so we could talk.
Nice. That's great.
It's gonna show up on your phones tomorrow. I mean, your phones tomorrow, your desktop phones. So that's it, guys. We're done a little early, but you'll see the final presentation at some point. Thanks for coming. When did I make a decision? Oh, and we find out the 18th whether we won or not. Yeah. Fingers crossed.
Brian or Ellen, is there anything that you would have wanted to do differently? Like you kind of mentioned, it'd be ideal to be on the project earlier.
Yeah.
Is that the only kind of thing, maybe, or?
I mean,
What would you want?
it's hard to say. It's always better to at least, instead of just like receiving the form, at least having like some idea of what the project is, and just like understanding it. So we can kind of negotiate these things and talk through it, like the entire design process with the team up front.
Just like any designer would want, you'd want to know all those kind of
Yes, I think
conceptual approach to it. And,
that was my biggest pet peeve.
you're not a
Actually.
tool.
Yeah, we're not a tool.
You're-
Well, I'm a tool.
Tool.
Alan's not.
You're kind of.
I'm kind of a tool. I think not being involved from the beginning, right? I think not being invited to a lot of the design meetings. I think not being a part of the narrative. And, it wasn't just like how we felt, right? Like, okay, here are my feelings, like, I don't care. But it was about being able to have like some kind of feedback with the design team where it's just like, look, we're actually taking all of these design asks and we're building it into a system which strengthens your story, right? And it wasn't until kind of like the last days when we're putting the final presentation together that like we got those threads into the narrative, right? Like, the tomb of Shikandar, or the fact that we're like playing off this jelly that we found kind of the example of. And like all these things that were incorporated into the design. It's not just like, oh, we're designing in Grasshopper and that's the design. That has nothing to do with it. Right? It's we're doing a system that's like responding to a lot of what the client had asked for
Yeah.
in a very intelligent way. Like, don't just like think of this as like grasshopper spit something out.
Right.
And there was actually a moment that has stuck in my mind where Tomas, like at one point, he's like, "Oh, how'd you guys do this? Like, did Grasshopper do this?" And he said, like, "Did Grasshopper do this?" And I'm just like, "No, we actually like we sketched it out, we built a model of it. Like that's like any design model."
Yeah.
So
Grasshopper doesn't do anything.
yeah, Grasshopper doesn't do anything.
Right. For sure. Make it into
My questions come from more of a place of, I always feel like I'm trying to just synthesize all of our, what we have available to us in the office and just to try to better understand what makes sense in that kind of process. And as, for instance, just starting on Omaha right now and wondering, you know, if there's a place for something like this and when it would make sense to bring you on board if that were the case.
I mean, it's when you guys have design kickoff.
Yeah.
That's the time.
Yeah.
We can talk about like if you need us or maybe you don't.
Yeah. Yeah.
It really is based on the kind of the ambitions of the design team.
Yeah.
Like, what are you guys trying to do? Like, this may be complete overkill for you guys.
Yeah, well, I mean, I certainly look at it and see money
Yeah. Oh, there's a lot of money.
on one hand.
No,
So,
you're looking at it with the wrong.
oh, sorry.
Yeah, you said that. I was thinking it's just expensive. Well, the one thing that I think we did say to the client is that this is the bespoke system for the building. You know, like everything else is very straightforward. We're not doing any kind of complex structural, any kind of cladding is very more just a curtain wall.
Yeah.
And then this piece is the sort of the signature piece.
Yeah.
I think if this goes into development, then I think the real work will be how to. My sense is that right now the forums are, if you were to unroll them, they don't have rectangles; they're like taper. And so that means that the grid is made of every cell. What we could do would be to say, okay, one possibility is say there's a field of regular, and then there's like a fringe or an edge that can transform to go to those square edge geometries. Another would be to say that the joint between each one of those cells might have the capacity to take up maybe 30 to 50 millimeters of distortion.
Mhm.
And that through, aggregate distortion, you would be able to kind of create. Because I think if we're clever about how to approach it, there's probably some very interesting ways of solving it that get the sort of number of unique units into a match.
Yeah.
Brian, that's where you
I mean,
are
so-
really going to need to shine.
So
is that-
to but to your point though, and I think this is where your question was leading, is like, how would you guys work with us, right? And like,
Yeah, essentially, like,
and I think
and-
there's a few different flavors, right? It's like,
Yeah.
the first step is just like bring us into a design meeting and we'll talk about it.
Yeah.
Right? And like, what are the design ambitions? Like we were fully immersed in this project for 2 weeks, more like 3 weeks, right? With all like the post-production that we had to do.
Uh-huh.
So one is like being fully immersed. The other is like doing a design assist, where we kind of like work with your designers, right? Give them the principles that they have to work with. Give them as much training as they would need to kind of just operate the tools.
Yeah.
Right? And then the last flavor is just like, here are tutorials on how to use Grasshopper and like do with it what you want. I think what the office like doesn't realize, or what they're beginning to realize, is like we're not just bringing like knowledge of the tools, we're like bringing knowledge of like designing according to the system.
Yeah.
And like a systematic way of designing, which like a lot of designers just don't. So, but first step is
because
let's
for
talk.
example, like maybe designers in the office who are leading the project, who aren't as aware or as do not have the understanding that it would be beneficial to have you on board at first.
Yeah.
It, like, I'm sure that conversation didn't happen at all with Omaha.
Yeah.
And so, yeah, I guess a lot of times I want to come to these things not necessarily because I'm going to be using these tools or doing anything myself, but I want to better understand the process and what we have available.
I mean, to be honest, like one of the best things Chuck did was like sit us down, give us a brief, and like just let us run with it.
Yeah.
Mhm.
And just like got out of the way and was just like, just do your thing. And
Yeah.
like he wasn't overly handsy with all the design direction.
Yeah. Yeah.
You know, and then like when it came time to
That's the beauty is I think when you have skilled people, you don't need to give them like some rules that you're hoping to achieve and say, okay, do it.
But you initially came to them with an idea of skin
Yeah, and actually I would say.
on a building.
If you was-
it
Or
was
not.
exactly what the first 3 points.
Yeah.
It has to be a skin.
Yeah.
It has to kind of be evocative of a traditional jelly,
Yeah.
and it has to have depth.
Yeah.
I mean, that's like all he said.
Yeah.
You know, I mean, there was a lot more that was said, but like,
Right.
that was what it was distilled down to.
But also, I think the Apple project that Anthony just finished,
Uh-huh.
that was a very key sort of influence on really, A, we know how to do something like this.
Mhm.
We don't know, it's not a fully developed concept, but we know how to make a kind of molded, sculpted system
Yeah.
that can be part of the shading and have, all sorts of features. So I think that kind of took away any kind of anxiety or fear that, are we going somewhere that this is gonna be ridiculous?
Yeah.
And I think that, so there was confidence in knowing that the system could be executed in a way that, knowing what the cost impact and knowing what the sort of parameters of the material and things like that,
Yeah.
those all sort of, I think, created like a foundation of confidence that said, hey, we're not going out into an unknown zone that we're gonna have to do a huge amount of.
That gave Chuck and Anthony confidence. We already were.
These guys, they're fearless. They say, we are going forward.
At the end of the day, because like we were designing with geometric principles in mind, like if you can just describe it geometrically in a simple way,
Mhm.
like you can most likely build it.
Yeah.
So we were, we were there.
Yeah.
You guys, you did an amazing job, like from start that, basically in 3 days, we were looking at a system that had transformational possibilities. And then we're still developing the sort of the overall massing and how this thing is going to like cloak the forms.
Mhm.
And
That was the
they were,
most
like,
time.
resolving the way that the transformation would be able to happen, not just in a kind of a graduated linear thing, but then Alan developed this kind of ability to create like a kind of hot zone on the facade and could transform it in a way that allowed it to be curved so that it wasn't evident that you're just kind of going through a linear progression.
And honestly, like that was such a good tool to communicate with Chuck and with Anthony. Like just having like simple surfaces like this is open, this is closed, right? Like that, it was a really good communication tool for like them to understand how the system was actually working.
Yeah.
Right? It wasn't like what's the final output. It's like what are the input surfaces, and that like let's design those, and then the outcome was the outcome.
It's kind of like designing with a diagram
Designing with a diagram.
that we were like working together on.
Yeah, then they give us this one module. It's just a very simple cruciform module. And I could not, I would look at it and say, oh, I get it. And I started to draw it. And then I'd look at it and go,
Yeah, no, you don't get.
And then I'd start to draw it again. And then I'd look at it and I go, wait a minute, I made all the wrong assumptions. It's amazingly, in its simplicity, it's incredibly complex.
Yeah.
That it's like, I go like, well, they rotated this. Well, yeah, they did rotate it, but they didn't, it's not, it has to line up with the next one. I go, yeah. Like, okay, I'm getting it.
Mhm.
But even now, if I had to like attempt to describe it, you know, I tried to draw it in 2D and CAD,
Mhm.
section, elevation. And I would still need to look at that object to actually, in my mind, to kind of reconstruct it,
Yeah.
because in its simplicity, it's incredibly complex.
Yeah.
It's like those Escher drawings that you go, oh yeah, I get
Well,
it.
as you showed that image, I was just trying to imagine in my mind. It's like, wow, he did that just in his head.
Yeah,
Just like
but
drew that. I mean, it'd be interesting to see
it
his
would be
process.
great to see the
there.
diagram because it's just a hexagonal grid.
Yeah.
Right? And
Yeah.
he's just filling it in differently.
Yeah.
But which is still very difficult to do.
Sure.
I mean, he's basically
Pretty cool.
manually doing how we developed this. Like, this is actually much more simple than some of Escher's stuff because he's, drawing birds and transforming. But the basic componentry is he's got a hex grid and then defining those shapes based on a parameter along the edge of the grid,
Mm-hmm.
and other parameters. Maybe there's lines drawn or whatever. But he's like, all right, well, if I have a line to transform from this bird into this fish, I'm just shifting the point connection along that line from here to there. So it's it's very
So
computational.
it's like
principle,
this
yeah,
fish
just-
face needs to turn into this horse's foot.
Exactly.
Right, but I'm sure he did it that way. It's like hexagon. He drew the fish within the hexagon,
Yeah.
and then he went to another hexagon. And he's like, okay, well here's the bird,
Um,
right? And then he did the transformation between them.
Yeah.
So very
It's pretty cool.
logically, it's computational.
Mhm.
He just manually did it. So that's essentially that logic is set up. So when Grasshopper is used, it's a tool. It's just you're able to iterate through it faster than
Right.
Escher could with his hands.
Right. But you guys have to understand the